This is AP Calculus AB Worksheet 1-6, average rate of change. In number one, we're trying to find the average rate of change over different intervals. And the way that we're defining h of x is it's a composite function where you find g, you put it into f, and then you subtract 6. So first we're doing f, so I don't even need to worry about this h function until down here. So just looking at f between 1 and 4, the general idea here is the slope between 2 points is the y-coordinate of 1 point minus the y-coordinate of the other point, all over the x-coordinates subtracted. And again, they have to be the same order, so 4 should match 4, 1 should match 1. If I somehow had the order reversed here, then I would have an answer that's multiplied by -1. So if I do that, I have to use a table. So to first find f of 4, I'm finding f of 4, and then if I come down here, that's going to be -1. -1. I'm going slow on the first time to make sure people can follow me. So f of 1 is 6, so I can say minus the 6 all over, still the 4 minus 1. Okay, now I can just zoom in here, do some math, and I can say -1 minus 6 is a -7. 4 minus 1 is 3, and I have my slope with those 2 points, my average rate of change. All right, now let's do the same thing with g. So in order to find that, I'm going to say g of 3. I like writing out the formula. G of 3 minus g of 1 all over the 3 minus 1. And then we just have to find g of 3 and g of 1. So g of 3, looking at the table, g of 3 comes down here to 4. And then g of 1 comes over here to 2. And then this is all going to be over 3 minus 1. So zooming into our fraction again, this is just going to be 2 over 2, and that simplifies to just 1 for our 2-point slope. All right, and then this is going to be the hard one. So the average rate of change of h. So I need to plug into h, and h is this thing right here. So I'm going to copy this thing down twice to begin with, because that is the y-coordinate. So I'm going to say it was f on the outside, right? So I'm going to say it's going to be f of g of something minus 6. This represents the first y-coordinate, and then I'm going to subtract the next y-coordinate. It's going to be f of g of another point, and then, sorry, I need to subtract 6, and that's all going to be divided by the 2 numbers that are being subtracted. So what are our 2 numbers? I haven't even looked. So it's from 2 to 3. So I need to come over here and say, okay, this one is from 2 to 3, 3 minus 2. Okay, so now the entire slope is ready to go. I just need to do some plugging and chugging. So first I'm going to find g of 3. So to find g of 3, I come back over here and say, okay, g of 3 happens to be 4. So I can come over here, and this is the way I like to show my work. I just like to cross this off and say, okay, this thing goes to 4. And then what about g of 2? G of 2 comes up over here. We say g of 2 comes over here to 3. So I can say that's going to turn into a 3. And my new problem is now f of 4 minus, f of 4 and the parentheses, f of 4 minus 6. And then I'm going to put that in parentheses so I can just, I don't need the parentheses, but I just want to remind myself that's a y-coordinate. And then I have f of 3 minus 6. And that's all going to be divided by 3 minus 2 is 1, so I can say it's 1 here. And then in the next step, I'm just going to not have any denominator. It's just going to be a numerator. Okay, now I need to figure out what is f of 4. So f of 4 comes here to -1. So this is going to be a -1. And then f of 3 is 10. So I come down here and say that this is going to be 10. So my new problem is going to be -1 minus 6 minus this 10 minus 6. And then again, I don't need any denominator, so I can just simplify this. -1 minus 6 is a -7 minus, I'm just copying down the minus sign. And then 10 minus 6 is 4. So we can come down here and say 4. And -7 minus 4 is -11. All right, moving on to number 2. So continuous means we don't pick up our pencil. Piecewise means it's made out of pieces of functions. And it's what type of functions? Linear. So piece of a linear, piece of a linear, another piece of a linear, another piece of a linear. And we're supposed to find the average rate of change, or at least sketching a line of the average rate of change. Again, I kind of cancel that out for the word slope, for the entire time interval from -3 to 7. So I just draw a line from -3 to 7, and luckily I have technology to make this a straight line there. Okay, so there's our line, so I can say check. That's done. And then for part B, find the average rate of change. Again, I'm kind of thinking of the word slope there, between -3 and 7. So you can use the formula, and I'm going to do that. And then I'm going to show you a second way that you could do it. So you could say this is g of 7 minus g of -3 all over 7 minus the -3. There is a double negative, so be careful about the denominator. It is going to be a positive 10. G of 7, how do you figure that out? You look at the height at 7. So I come over here and say, okay, 7 has a height of 1, so I'm going to plug in a 1, minus, and then -3 has a height of -4, -4, and again a double negative, so be careful here. And this is going to be 5 over 10, which simplifies to 1 over 2. There's the average rate of change. The slope between those 2 points is a half. So here's another way that you can do it. You can actually think of this thing as a giant staircase, right? You can say, okay, I've gone to the right plus 10. How do you know that it went plus 10? Well, you can count, right? So I was at this point, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got my plus 10. And then how much up did I go? I went up 1, 2, 3, 4, 5, and you can label over here, that's 5. And then just using this graph, you can say, oh, and I should say it's a plus 5, I should have signs there. You can say it's the rise over the run, it is 5 over 10, and then that does still simplify to a half. So yet another way to do that. All right, so moving on to number 3. We have this table, and it represents the number of concert tickets, and yep, we have a bunch of information. The only thing that I care about is the average rate of change. Again, I cancel that out for the word slope. The slope between 4 and 7. So I can ignore everything else. So I can say, don't care about any of those. Don't care about any of those. I specifically care about those 2 points and nothing else. So to do that, you just do our slope formula. You say, okay, this is a capital L function. So capital L of 7 minus capital L of 4 all over that 7 minus 4. Again, make sure that you have the same order. And then when I do that, L of 7, I use a table. L of 7 comes down here to 50, or 150, sorry, 150. Minus L of 4 is 126. All of this divided by 7 minus 4, which is just 3. All right, the top of this function is going to be 24 over 3, and 24 divided by 3 is 8. We're not done yet, because while we did find the slope is 8, it says indicate units of measure. So this is 8 what? Well, we are dividing a y-coordinate by the x-coordinate. So it's going to be this unit by this unit. It's going to be people per hour. People per hour. And if you want to, you can say this one, or you can say it's people per hour. I know some people like to write it this way. I just like fractions. That's my preferred way of writing it. It's whatever you like. Whatever floats your boat or sinks your sub, as they say, right? All right, number 4. We've got a metal wire. Things are happening. Luckily, these easy questions in Unit 1, you don't have to worry about the context too much. Maybe the units will come back to bite us. Who knows? Okay, so find the average rate of change. Again, find the slope between 0 and 5. So we're talking about capital T in this case. So I can say capital T of 5 minus capital T of, was it 0? Yes, 0. Capital T of 0. All of this divided by 5 minus 0. It's the same formula over and over and over again. Okay, so capital T of 5, I use a table. Say, okay, capital T of 5, that comes down here to 70. And minus T of 0 is 100. This is all going to be over 5. 70 minus 100 is negative 30. And negative 30 divided by 5 is a negative 6. And I believe, yeah, it does say indicate units of measure. So 6 what? We're dividing a y-coordinate divided by an x-coordinate. So it's going to be a y-coordinate unit divided by an x-coordinate unit. It's going to be degrees Celsius per centimeter. And I really should be boxing my work. I don't know if I boxed the last one. Let me come back and check. I did not. So I'm going to say 8 people per hour. Boxing. Okay. Number 5. Got an interesting graph up there. It even tells us an equation of stuff. Okay, so sketch the line representing the average rate of change. Again, change that to the word slope. Between 4 and 24. So between 4 and 24, I'm just going to make a line that connects those 2 points. Oops. Luckily, I have technology to fix that for me. There, done. That's just the slope. And then find the average rate of change. Find the slope of that line. Again, I could do it that other way that I was just talking about, where you come down here and you make this triangle shape, and you can say, oh yeah, this is, I go down from 9 to 6, so I go down 6, and I go from 4 to 24, so I go right 20, and then you can make this fraction that is -6 over 20, which reduces to -3/10. There's another way to do that, which is to use the formula. You can say, well, this function up here is lowercase f, so you can say lowercase f of 24 minus lowercase f of 4 all over 24 minus 4. So f of 24 is 3. F of 4 is 9. How did I find that? F of 24 is the y-coordinate at 24. F of 4 is the y-coordinate at 4. And then all over 20, which is a -6 over, I was about to write 10. I was thinking ahead to simplify. And then I'm going to divide the top and bottom by 2. And this is going to be a -3/10. I don't know if I said a negative in my original answer, but it should be a -3/10. And I'm not done because I need to indicate my units of measure. Again, this is my y-coordinate divided by x-coordinate. It doesn't say anywhere in the problem down here what those those units are, but the graph up here does say it's degrees or calories per minute again. So I'll say calories per minute, and then you can say all over per minute. That's the easiest way to do it. Although there is another way that you can say this. You can say calories per minute squared. Oop, that was a terrible rectangle. Let's try that again. Please connect. There we go. And lastly, we have number 6. So again, I'm going to kind of ignore the context. It doesn't matter for these types of problems, luckily. Find the average rate of change between 0 and 90. So 0 and 90, just connecting those 2 points. And we have our secant line. And to find the average rate of change of that line, again, it's one of those things where I could totally just go ahead and do this. Ooh, that was maybe not the best. There we go. And then I can say, okay, I went from 0 to 90, so I went plus 90 over here. And then I went up from 20 to 70, so that's plus 50. And that's 50 over 90, which is 5/9. So you can do it all in your head, kind of. Again, you don't have to do it that way. You're talking about a capital R function, so you could say it's capital R of 90 minus capital R of 0 all over 90 minus 0. You could go back to the formula. R of 90 is 70. R of 0 is 20 all over the original 90 that I talked about. So that's going to be 50 over 90, which reduces to 5/9 if you divide the numerator and denominator by 10. And we're basically done, except for the fact that we need units of measure. So it's our y-coordinate divided by our x-coordinate. So this is rate of fuel consumption, but those aren't really units, and time isn't really units. You want minutes or something. Yeah, so it says minutes right there. So, and then what is our y-coordinate measured in? Oh, it says it right here. Our rate of fuel consumption is this units, gallons per minute. So it's going to be gallons per minute per minute. So we're going to come down here and say this is going to be in gallons per minute. And I can box that. All right, guys, that does conclude our worksheet 1-6 for AP Calculus AB. There's the back, there's the front. Thanks for watching.